My name is David Pallmann. I'm a product manager at AWS, and I am focused on .NET developers, which is a fun job for me because I've been a .NET developer since .NET came out, and I am very devoted to it. And I know you all are too, or you wouldn't be at this conference. We're going to talk about .NET Aspire, which I find incredibly exciting, and how you can use it with AWS. Let me ask, how many of you here use AWS? Okay, a lot of you, not unexpected. And how many of you do cloud native work? Yeah, just a few. I bet a lot of you are thinking about it though, or you wouldn't be here. All right. So why .NET Aspire? Well, what is .NET Aspire? It's been described in a lot of different ways. It's been described as an opinionated, cloud-ready stack for building observable, production-ready distributed applications. It's also been described as an opinionated stack for building resilient, observable, and configurable cloud-native applications with .NET. And as a set of tools, templates, and packages for building observable, production-ready apps, which is the correct definition. Well, they're all correct. They're all true. Now, you notice that word opinionated is in there. And why is that important? Well, if you think about other platforms, like, say, Ruby on Rails, the way it got a large following is it was opinionated. It came with a set way to do things, and if you bought into those opinions, it was easy to use because a lot of things are built in, like observability, things you'd want to do, but maybe weren't necessarily an expert in. And that's maybe the one thing that's been missing from .NET is this idea of an opinionated stack, a way to do things that would make things easier. And now we have it, and I'm very excited by it, and I think you will be also. So why .NET Aspire in AWS? Well, as I just mentioned, .NET Aspire is a big deal. And it is a multi-cloud platform, which means not only can you use it on Azure, but you can use it on AWS and any other platform that provides an implementation. And you may not know this, but AWS has supported .NET since 2008. And we're very beholden to .NET. And in the .NET Aspire work, AWS and Microsoft have been working together in a very public, professional partnership, and which I find really refreshing. Puts the customer first, and I'd love to see more of it. And .NET 9 shipped with AWS support. So if you're using .NET 9, you already have the AWS support. You don't have to go and find some package. You have it already. And you may have seen last year our principal engineer on Aspire at AWS is Norm Johansson. You may have seen his .NET Conf session with Scott Hunter. You may have seen his .NET on AWS Twitch show with David Fowler. So again, good, strong relationship, and we expect it to keep paying dividends. So I'm going to show you today, I'm going to switch to Visual Studio, and I'm going to show you a fictional pizza chain's explosive growth and how that has forced them to move to newer and newer technology, and how .NET Aspire helped them. It's always good to have an example, some context. So here's the backstory. Back in 1970s New York, where I grew up, Italian-American immigrant Luigi Pallmann started the pizzeria. And everybody loves pizza, right? If you don't like pizza, you probably aren't welcome here. But we really like pizza in America, and we really, really, really like pizza and are very snooty about it in New York. Well, Luigi taught his son Vincent, as he was growing up, everything he knew about pizza. And when Vincent grew up, he took over the pizzeria. Well, Vincent's employees started a tradition after closing of making unusual pizza every weekend. And some of them were pretty wild. Cheeseburger pizza, Greek pizza, Mexican pizza, breakfast pizza, seafood pizza, Oktoberfest pizza. Some of them were interesting, but some of them really, really worked, and it became a tradition. Well, customers heard about this, and they started demanding these fusion pizzas. And when a food critic wrote up about these oddball pizzas, Vincent knew he had a winner, and Oddball Pizza was born. Well, Oddball Pizza saw some pretty good growth from their original single store in New York City back in the 90s, where the way customers placed orders was to call 555 Pizza, and the technology they used was called the telephone. For you younger folks, there used to be a time when everyone had a thing called a landline, a telephone number that stayed with the building, not with the person. Very different from today. 10 years later, by 2000, they had 5 locations, again in the New York City area. The .NET the dot-com boom was happening, and so they had to have a website. But their website was just a static web page. It literally was a menu and call 555 pizza. So their dominant technology was still the telephone, but they did have a web server. Fast forward another 10 years, 17 locations across New York and New Jersey. And they've moved to .NET. They have a simple ASP.NET website. So the technologies are .NET Framework in Windows and SQL Server, and they're running that on Amazon EC2, virtual machines. And their architecture, of course, is the monolith, one big application. 2020, COVID hits. Very good for the pizza delivery business. 47 locations across the eastern United States. They have modernized to ASP.NET Core so they can run on Linux. And, but still, their website hasn't really changed very much. It's still an older monolith. See, Oddball Pizza is not what you would call an early adopter. They use new technology when they are forced into it because the times are changing or because growth requires it. And they're still on a monolith, but now they're using .NET Core on Linux. They have moved to managed services on AWS, so they are using Elastic Beanstalk instead of EC2. That gives them automatic patching, and they are using RDS SQL Server, managed SQL Server database. But they're really behind the times, and they know it. And by 2025, up to 81 locations, and continuing to expand, they're really concerned because now they have to go beyond one cloud region. They are looking at going global. They're going to expand across the United States. They're already getting franchise inquiries from Canada and the UK, and they don't know how to do it. They know their cloud use up to now has been kind of minimal, and what do? And they don't know what technologies to use. They hear their architecture should change. They're really full of questions. And what are some of these questions? Well, they know they want to eventually have a mobile app. They know their web UI is really out of date. They're thinking about things like social media sign-in. They see what their competitors do, but they really don't know. And they know they have to get ahead of the technology instead of playing catch-up, but they don't really know how. They're being advised to move to microservices and containers. Observability should be there, but they're not experts in that. They're being told to abandon their beloved relational SQL Server database and go to NoSQL. This terrifies them. And they should be looking at something called serverless, which mystifies the IT people. They really are just full of questions. They want to do the right thing, but all these things seem interrelated. And when it finally dawns on them that they kind of are interrelated, that what they're talking about is cloud native, a different way of thinking about your technology, designing for the cloud, they start to get some clarity there. And when they find out about .NET Aspire, an opinionated stack for building cloud-native applications, this is where they get really excited because finally they've got some help, a certain way of doing things that will give them a lot, not everything they want, but a lot of what they want, a good foundation for that, and a certain set way of doing things that they can be confident in. So they plunge into .NET Aspire. So now we will do this, and let's see how a fictional growing pizza chain's journey to cloud native is helped by .NET Aspire. So for starters, what I'm going to do is I'm going to start with a practically non-existent app, and we're just going to fast forward as they make changes and look at what was changed and what it does for them. So initially, Oddball Pizza's got, they put some work into UI. They're interested in Blazor. They never worked with it before. They're probably not doing it right, but they have started to build out Blazor pages, and so they've got this idea of a whole new website UI. We'll see it in a second here. They don't know much about components, but they figured out how to do a checkout page. Again, they're really feeling the way through a lot of technologies at the same time. And they know this microservices thing, again, they're very unsure about it, but they know they need some kind of order processor on the back end, and that actually has no implementation yet. Their website has a UI, but it doesn't do anything yet. But still, let's see what they have so far. All right, now if we're up and running, then we have a UI that looks like this. So the idea is they have these different classic and unusual oddball pizzas. And here they've just put a couple in. They have 4 or 5. But they've done the work to figure out how you would place orders, right? So they're very proud of the new UI compared to what they used to have. And They've even done the checkout page. But it doesn't do anything, right? It's just a UI. It's okay. That's a starting point for them. And as I said, the back-end project exists, but it doesn't do anything. What else have they done? Whoops. Well, they have started some models, right? They have figured out what an order looks like. They have figured out what a payment looks like, what a product looks like, and that's what they have. So as they start going forward, they think to ourselves, well, this .NET Aspire, maybe we should be using that to help us experiment and prototype and figure this out better. So let's fast forward to an app that's been instrumented. And by the way, if you have existing apps and you want to add .NET Aspire, right there in Visual Studio, you can right-click and instrument for Aspire. It's pretty cool. All right, so now they've instrumented for Aspire, and it's added a couple projects. One of them is called App Host. This is, now if you've worked on multiple services in a solution ever, or maybe you haven't done that, you got this idea of startup projects, and you got to say which projects am I going to launch and which or start with and which one are not. But the App Host is something that launches everything together, and you'll see in a minute why that's useful. So the App Host looks like this, and it creates a distributed application in the builder, and we tell it about two services, the website and the process orders, and so not very complicated, but you'll see this grow. And there also is a service defaults page. Different extensions you can configure there, technologies. So we'll run this, and what is our starter project? The App Host. The App Host is all you need. Let's run. Oh, what's this? Well, we have been given a very cool dashboard. You'll see our two projects are represented there. So there's the process orders and the website. They're both running. Tells us what source projects they relate to. And for the website, it knows there's an endpoint, actually two endpoints, HTTPS and HTTP. And there are logs we can view in details. Let's look at details. Details for the website. It's running, and tells us endpoints, and there are a whole bunch of environment variables. These will become increasingly important as we look further. Let's make it all visible. And you'll see some of these are things you would just get with ASP.NET Core, but some are things like OTel. What is that? Open telemetry. Right? Open telemetry has been added to our projects here automatically, and it's going to give us great visibility internally once we actually build some functionality into these projects. And likewise, you can look at details for the process orders, which right now is very boring, doesn't do anything. Well, what else do we have besides resources? Well, we can look at the log consoles for any of these apps. So here's the website. See, it's doing its thing. It's initialized, process orders. Likewise, not a lot happening there yet, but this will be great to see later. But we also have structured logs. We can look at structured logs for any particular service, or we can look at them all together. And then we also have something called traces and metrics. We're going to come back to that a little later on. So we've got this very cool dashboard, and we can launch everything at once, and we still have a solution that doesn't do anything yet. So let's start doing that. One of the things we could do is we could, in our UI, we could drive this menu from an actual table of products rather than just being hard-coded for tests like it is right now. So let's do that. So to do that, thinking of being, let's open the right solution here. So I happen to have created a NoSQL table called Pizza Product that has the menu, and I could go over to the AWS console, but I don't need to. We have a database toolkit. So we have an AWS Explorer right here in Visual Studio. Let me refresh this. Working here in London. And you'll see for Amazon DynamoDB or board purpose NoSQL database, we have a pizza products table, and it's populated. It's got country, and it's got different product names, description, image reference, and how to categorize it, and a price. All right, so since we have that, how can we get that connected here? Well, we can, we've added a new project called Product Service. I think microservices here where a microservice owns control of a table or two and is the conduit to it. And so, but we want to use DynamoDB. So how do we do that? Well, we had a package for DynamoDB, and we launched a couple. Now we've got a couple different services in here for DynamoDB because there are a couple different ways to use Dynamo. There's the low-level library, the high-level library, but my favorite is called the .NET Object Persistence Model. That's a really easy way to annotate your models and just have Dynamo do the right thing. And so we can see if we look at the models page for product, we have a couple attributes. This goes to DynamoDB table called pizza product that I just showed you, and these are the keys. Right? So a partition key and a sort key. Well, in our process orders service then, product service rather, so we have the Dynamo stuff injected, and actually this is just an all-in-one, so we have just a simple map get here to get the menu. So we have database client, database context for the .NET persistence model. We want to scan everything, return it. Really simple, small amount of code. And in the website, in our Blazor uninitialized, we want to retrieve the menu. And that's just a matter of talking to the product service. But how do we talk to the product service? Well, the way to do that these days is to use what's called a dedicated HTTP client. If you're going to use .NET Aspire, you're going to use some other .NET constructs that are recommended that are in the same vein. And so let's see. We're going to say we're going to use an HTTP client for products called product client. And this is where we use something called service discovery. Service discovery is a very exciting thing in Aspire. It says, well, I know I have a product service. I don't really know where it is. Find it for me, please. After all, it might be in a different place locally than when I deploy later. We want the code to always work. So if you look at this here, it says we're adding an HTTP client, and we want the address to be, and this is a very odd-looking thing, HTTPS plus HTTP : pizza-product service. Now, pizza. This is not the URL of the service at all. But if you remember when we registered earlier in that post, we looked at this a minute ago, it had our projects listed, and the product service has been added here. Pizza product service. That's that same name, pizza-product service. So Aspire is going to know how to find this. So let's try it out. All right, so you notice we have the product services also listed here now. It's got a log we can look at like everything else. But let's go to the pizza website and launch it. We can do it right from the dashboard. And this should be loading our menu. And it should be you can see from the list here, it's a much more extensive menu. Now, actually, if let's say we didn't code this quite right. Let's say, I got the name I didn't get the name right. I remembered it wrong. loading menu seems stuck. Something's wrong, but what? You know, as we build out a complex distributed system, it's going to be hard to know why things fail sometimes. Well, this is where we can really get some help. We can start to see, by looking at logs or traces, that, oh, something is wrong here. We start to get details. Oh, there was an error. A name resolution error. Okay, that tells me that something was probably wrong with the name there. So if I'd had this problem initially, that's how I would have figured out what's going on that was wrong there. So. All right, so we've seen DynamoDB used easily, and service discovery, which is very exciting, and the ability to debug out of the dashboard. All good stuff, but let's move on to even more. Now we've got this front end that doesn't do anything other than have a UI. We've got this back end that doesn't do anything yet, but they will do things, and we would like to connect them. We'd like to use messaging so that when an order is placed on the front end, that order is sent to the back end. It's a very natural thing we'd want here. So to do that, we're going to need some messaging tech. So if we go here to our app host now, we're going to see now that we have really instrumented the Aspire app to be able to create AWS resources. So one of the technologies we have is called CloudFormation that does basically a very long amount of JSON or YAML will create resources for you, infrastructure as code. But what I find much more exciting is called the CDK, the Cloud Development Kit. And that's a way in C# to specify resources you want created. So what we've got here is add an AWS CDK stack. And that's going to be something that can create resources. And then you see below that, we are going to create an order queue and a topic. So we're using the simple notification service, Amazon SNS, to do pub sub. So send something out on a topic, and that topic, those messages can go to any number of recipients. But one of the subscribers will be a queue, a simple queue service. So we're creating an SNS topic and SQS queue just to keep our options open for the future. And how does this magic work? Well, let's take a look at our CDK stack. This is an approachable piece of code that knows how to create things. And that's actually what we go on is this file called app resource stack. And you'll see in here a couple things we want to make available. So there's an interface for a topic and a queue, order topic and order queue. And then creating the resources is astonishingly easy. This is how we create an SNS topic. New topic with a name. This is how we create a queue. New queue with a name. Order topic, order queue. And this is how we subscribe the SQS queue to the SNS topic. So really small, simple amount of code. So how do we interact with these queues and topics? Well, if we look at the website code now, we've added to this AWS resources. These are going to get access to the resources we just saw created in the app host project. And we say bind, and so that makes them available to this project. And here we're creating something called, now if you've ever worked with, any of you worked with SQS or SNS in the past on AWS? Yeah, so you can use the AWS SDK for .NET to talk to that. But we have something kind of cool. We have a number of frameworks we built just for the .NET developers that not everybody knows about. One of them is called the Message Processing Framework, or MPF. And that's this, and here we say we're going to add an AWS message bus, and we're going to say the source is this project, the web app, and we're going to do an SNS publish of order messages, and we can inject that as a iMessage publisher into our Blazor app. And so that's a nice simple way. And what's nice about it is if later on you change messaging technology, for example, if you used AWS Event Bridge, more sophisticated pub sub, you don't have to change any of your code. So it's a nice way to do messaging. So in our Blazor app proper, once the UI is done so already, submit payment. What does submitting an order look like? Well, we're going to get the order crafted right and encrypt the credit card number and do some logging, but actually the messaging to publish this to the simple notification service and ultimately land on a queue for the back end, it's just a publisher async. And publisher is just this injected iMessage publisher. So really easy messaging. So on the back end, remember that process orders project that doesn't do anything? Well, now it does do something. It is also does a bind to AWS resources so it can find things. And it has a message bus, message processing framework piece of code here to add an SQS polar right, on the order queue. And again, it doesn't know the name of the queue, but that's in our Aspire resources, so we can find it easily. And it's the big key thing is saying, hey, when we have an order message received, order handler is this class that's gonna respond to it. All right. And so on the back end, all we're gonna do is really log that we got the order. But so that's really all we do here is the detail. But let's see this work. F5. Okay, there's our Aspire dashboard, and by the way, we have something new. We have the CDK stack itself. And so why isn't it started yet? It's still starting. What's going on? Well, we told it to provision some AWS resources, add an SNS topic and an SQS queue. So that'll take not too long to provision. But the CDK stack here is listed as a project because anytime you want to, you can browse to that. At the end of this demo, if I want to delete all of the AWS resources, that ultimately would be quite a few that we're going to allocate. See this endpoint here? I can just browse to the console and find it if I want to delete it, for example, or look at it. So, all right, that didn't take too long. And let's give it a shot here. So we're going to go to our website and sort of some classic pizzas and some. You can see we have the full range of choices here, including very oddball ones. I myself. Use pizza. All right. So let's check out. And we'll use this fictional person, their fictional credit card, and place an order. Well, okay, looks like it placed the order okay. Let's see if the structured logs agree for the website. So, okay, got an order, submitted the order, so it thinks it wrote to the queue. The question now is, what about the backend? The backend has no UI we can look at, but we can look at its logs, the process orders. Oh, look, I got a new order. There it is, here's the details, it's all got good integrity, so that worked, and that was actually pretty easy. Oddball Pizza is starting to get excited even about microservices and NoSQL databases because this was kind of painless. And maybe they don't have it factored right, maybe they have to experiment quite a bit more, but this is giving them, building confidence. .NET Aspire has helped them leapfrog getting started, and even when they do something wrong, they have this huge visibility and dashboard to understand what's going on. So, what's really exciting when you do something like this between different services is that you can look at traces. So we can go here on the traces, and look, you see different things happening on different projects. But look here, pizza website 2 process orders, right? That's a trace. And we have a lot of detail about how things connect and whether they go right or wrong. So this type of visibility, especially as we build things out, is very, very, very exciting. All right, so in this leg, we saw the Cloud Development Kit from AWS. That's the way that we can provision resources on the fly. And we saw that the message processing framework is an easy way to do messaging. Next up, it would be good to have the order processing service store those orders. Now, we've already done something with Dynamo, but what about creating DynamoDB table here in the Aspire project? So in our app host, whereas we had already created the order queue and topic for SQS and SNS, now we're creating an order table. We have an order table. So what does that look like? Well, it's not a whole lot of code. A new table. This is the DynamoDB version 2 package for the SDK. So we're creating a new table. How do we want to be billed? On demand, please. And it's got a petition key or maybe a sort key. We're just doing one simple key and order number here. And removal policy is if I later on go and destroy the CDK stack that has all these things in one place, do I want the data preserved? Do I want it to refuse to be destroyed or not? Here I don't care, so that's fine. And then in the process orders, the receiver here for getting an order message where we were previously just logging it. Now we're going to store that. And that's really just a one-liner. The DynamoDB with the .NET object persistence model in Dynamo, you just save async of the order, and it's in there. There's nothing else to do except error handling and logging. So again, very easy. So let's try that out. Now, why the delay again? If we ran with the earlier version, did the SNS queue and topic, and we ran it a second time, there wouldn't be any waiting at all because it would see that the resources were already allocated. But here we asked for a DynamoDB, a new one at table, so it went ahead and created it. Didn't take too long. Well, I shouldn't say that, it's not done yet. Won't take too long. But as you run, when nothing has changed, you won't have any pause. So. How many of you have worked with Dynamo? Just a few of you. All right, so here we're up and running. So we're going to go and just do another order. And let's do something odd. We'll do Oktoberfest pizza. This didn't go well at first until they reduced the amount of sauerkraut in it. So. And for vegetarians, we'll do a ratatouille pizza or two. All right, checkout, and we'll do person this time, and place our order. Okay, so on the process orders page, if we look at our structured logs, okay, we can see order was received, and it claims storing order is stored successfully. Let's see if that's true. So one of the things we can do in our AWS Explorer is we can just look at the refresh here, do Dynamo, and look, our pizza order table was created. So there it is, and it even has the record in it. So all good. Now, for some of these, this might seem trivial stuff, but for Oddball Pizza, who has just been out of the loop on tech, not the early adopters, not the type of folks that go to NDC conferences. This is a godsend that they can do these things so easily and get out of trouble so easily. All right. Well, so far we've seen the front end, and it's starting to make things work and passing order messages back to an order processor that stores the order. But ultimately, for fulfillment, we need pizza locations. We need stores that are going to cook the order, and so they need to know about these orders and to have some kind of website for the kitchen to say, I'm prepping the order, I'm baking the pizza, it's ready for pickup, and so on. So let's look at that next. So we already created a queue earlier. And we know how that works. We're just going to do more of that. So we're going to. Obel Pizza hasn't really thought about how, for 81 stores, how they're exactly going, what exact message pattern for fan out they're going to use. But here, it's just starting simple. They're just say, well, I'm going to create a few store queues here and just kind of route things to store one, just to see how things work, and then they'll figure out how sophisticated they want to be about that. Again, they have different choices. They could use SQS, they could use EventBridge, they could use plenty of third-party messaging methods. So they're going to delay that decision for now, but they know what they're doing here will work with all of that. We have added now, in terms of the projects, Pizza Store. The Pizza Store is another Blazor project. And it really is just a way to look at work tickets and check them off is all it is. So once our queues are created, store queue is created, the process order backend needs to send the message, the order message it received and stored. It needs to pass it on to a store. So it's going to be in the order handler for the message. So as before, an order comes in, stored in the orders table, but now we're going to publish it off to the store queue. Again, that's a really easy publish async because we injected an iPublisher, and that came from the message processing framework, so which is here. So again, easy to code. So let's try it out. All right, so we see our number of projects is growing. Now we have a store. Just waiting for the endpoints here. Once again, I don't want you to get the idea that every time you launch Aspire, it makes you wait. It's just because each leg here, we've been adding more resource. So it's only the first time that happens. By the way, how many of you all are using microservices? Yeah, about half.
I take it the resource allocation is smart enough to know that I've already created this queue before. So
That's exactly right. That's why if I ran it a second time, there wouldn't be any waiting at all. Yeah, exactly right. All right, here we are. So we're live. So here's our store website, and it's empty until tickets show up, and tickets will show up once it receives an order. And of course, our front end. All right, so now that we have the front end and the back end, we can try placing an order and see if it all works. So let's order a Halloween pizza and a sushi pizza, which I find very questionable myself. And all right, Mr. Colton's order has been, has been placed. Ticket appeared. And you can start prepping that order. Let's do another one. Like a couple breakfast pizzas, please. Yeah, we're in business. We start baking and filling orders. Very exciting. Now, we could look at any of the individual logs and we'll see logging about that, but traces is where this really gets exciting. Website, the process orders, pizza store. You see how that chain is maintained there that you can take a look at there. And it's just awesome. And so far we haven't really been looking at metrics, but the metrics you get for all of this is just an amazing way. So the database CDK itself has all sorts of metrics. And these are the prettiest metric displays I've ever seen. And there's I won't have time to begin to cover all the different things that are here, but as you see, it's anything you want to know, it's probably here for you. It's good stuff. So, all right. So now we've got order message routing to the order processor, and then we've got that routing further to the store in a simple routing, right? And we've got the ability to see all of these traces, and so we've got an end-to-end messaging path, and it's been pretty painless. What should we do next? Well, maybe reviews are really important. How many people here use Yelp? I use it like every day. Nobody? Nobody here? How do you decide if a restaurant is a good restaurant? Do you use something else?
We scores on Google Maps, not Yelp.
Okay, all right. But we agree reviews are important, right? These days, everyone looks at reviews before they buy almost anything. So they want to have reviews. They want to have customer feedback entered. But the marketing people don't necessarily want bad reviews on the website. So they really like to be able to tell programmatically if a review feedback is good or not. So they want to use AI to determine the sentiment of a piece of feedback. So. The last thing we'll show here is adding a feedback collection, a sentiment analysis, and we can use a service called Amazon Comprehend for that. So let's see how okay. Let's open the right solution. Okay, so in our all-powerful app host project, we've added, this is a pattern we've seen already, of SQS queue and matching SNS topic for feedback, called feedback queue and feedback topic, and a feedback table, DynamoDB. We saw how to do it earlier, so I want to go into the details. Exactly more of the same. And in the website, and we've also added a feedback submission to our models, and it's because it's got a table, it's got some DynamoDB attributes there. And in our website, we have a feedback form. With the event surface there, we have a reviews collection page. And we'll see that in a minute, right live. And in the, we've had to add another service called, we had process orders earlier, now we have process feedback. Whoops. Process feedback also uses the message processing framework to hook things up. Exact same pattern, repeatable patterns are one of the joys of cloud native. And one of the joys of microservices is how simple everything stays. So things do not get tangled over time, and that is really refreshing, especially if you have staff turnover. So our order handler for process, or feedback handler for process feedback gets a queued piece of feedback, stores it in the feedback table, which again is a one-liner because of the DynamoDB object persistence model. But we want to do this sentiment analysis, and for that we need to call Amazon Comprehend. And I just want you to see how easy this is. So a sentiment request is we give it the text of the feedback and the language speaking, and we get a response, and a number of things in response, but we just care about the sentiment. We always want to know if it's positive, negative, or mixed, and bingo, we have it. So that's easy. So let's go ahead and run. Once again, we're waiting because we added an SNS topic and SQS queue. and a DynamoDB table. 3 things being allocated right now. Okay, we're alive, so we're going to go to the website where we can now say reviews. Now they haven't built out listing the reviews yet, that's coming, but this is the first step is collecting feedback and doing that sentiment analysis. By the way, how many of you, anybody here done any sentiment analysis for your company? Is that something you're looking at doing? Yeah. All right, so let's say that this person was very, very happy, not very, very unhappy. Crust tastes like cardboard. Sauce tastes like ketchup. Never again. Okay, not very happy. Let's submit the review. Let's do another one. Let's say magnificent. Best pizza I ever had. This is our new favorite place to eat. All right, we submitted some reviews. Let's see how the what's going on in the back end. So the pizza feedback service ought to have received the sentiment, and doesn't look like it did. Let's see if the order processing service. Interesting. Doesn't look like it arrived. I wonder what is missing here. So, but we should be able to debug that in Aspire, right? That's the purpose of this thing. So, let's take a look at traces. Okay, pizza website. Did no order. Okay, pizza website, the product service. That was for the menu. This is not planned, by the way. I had no intention of having to debug this, but it's a good test of Aspire, isn't it? So our feedback here, process feedback. Just taking a look at the logs, make sure something wasn't delayed here. Oh, there we go. So it took a little longer than I expected, but it did get the feedback, and so they're not very good. It concluded it was negative, so that's your sentiment analysis. It did get the magnificent feedback and concluded that was very positive. And then if we use the AWS Explorer in Visual Studio, we can see that we should have a feedback table added to our Dynamo tables. And there are records. So, all right. So that is the end of what I wanted to demo. But I just wanted to talk about a couple topics real quick. So, how would you deploy all this to production? Well, your IT department probably has very fixed ideas about deployments and CI/CD pipelines. They may say you things like, do it a certain way and we won't touch it because it'll break. And you may hear things like that. And some organizations are standardizing. How many of you folks here use Kubernetes? Yeah. And how many of you would never use Kubernetes? A few folks like that? Yeah, yeah. The word. So there's different camps, right? And so and container-based stuff could be run on an awful lot of different services, right? Like in AWS, every service we have for compute, back from low-level VMs on EC2 to container-based services like ECS or EKS with Kubernetes up to serverless like Lambda, all of those can run containers. So you could put your containers a lot of places. It would be the height of hubris on our part to decide where you can deploy this, right? We don't want to cause any disruption to your IT folks. But if you did want to deploy, say, any of these, like say the website, you could just do here in Visual Studio with the AWS Toolkit installed. You could just do publish to AWS, any kind of web-based or microservice load, and that will guide you through it. It realizes that. So in this case, it could say, I could put that on the Elastic Beanstalk service on Linux or on Windows, whichever you choose. Or I could put that on Amazon ECS with the option of going serverless with AWS ForGate. Or I could put that on AWS App Runner, which is kind of our easiest to use container service. Kubernetes is not listed here because that's typically done with the Kubernetes controls, but that's still available. So this is one way you could easily deploy things. And all those environment variables we were talking about earlier for service discovery and things like that are there so that set the right variables in your deployment pipeline and things still work. Now, how about going multi-region? What's involved in some of this tech we showed? How does it go multi-region? Well, one of the first things you saw me do was add a DynamoDB pizza product table so we could fetch the menu. Now, because this demo I originally created in the U.S. in the U.S. West 2 Oregon region. When I got ready for this demo last weekend, I switched everything over to London, but I didn't do that with the product table. The product table that we were using here was still in Oregon, so in the U.S. So why was it so fast? Well, because with Dynamo you can create something called global tables. So you can create matching tables in other regions, and it'll just keep them up to date. Whichever ones are updated, the others will just update. So we were actually using a global table here, and so it looks like it has a table in London, but that and any changes in the other regions, they just stay in sync. So global tables for Dynamo is one way to do it. The simple notification service, one of the reasons we did that for Pub Sub and on top of our queues is queues don't transcend regions, but SNS topics do. And so there's a number of fan-out patterns in AWS architecture that you can use to hop around the world, and that was the whole idea of Hubbable Pizza. Looking at this is how can we go global, or at least multi-region. So. All right. The last thing I'll mention is just when I'm done with this and I want to delete everything, what's involved there. So let's fire up our Aspire app one last time. Now this time I haven't made any changes, so I'm expecting a faster startup on the dashboard. Right. And we have the CDK project right here, and it's got an endpoint. So let's take us right to the AWS console if it hasn't timed out yet. Yep. Takes you right there to our app resources stack. And we can see what we've been creating over time. There's the feedback queue and topics and resources, order topics, pizza feedback. Everything we created, store topics and queues, they're all there. And so if I wanted to delete that, I can just I can do it in one shot. So. Okay, bye. All right, this is the end of my presentation, unless there are any questions. Sir, here in the red? Yeah.
Does AWS have a good platform for ingesting hotel data? What would you suggest as you're generating all this telemetry? Great, we have to store it somewhere if we're going to put this in production. What would you suggest is the best kind of AWS service for that use case?
You want to store what now?
Your telemetry data, because that's one of the key things here is we've seen a lot of metrics.
Oh, yes. So on AWS, you can use AWS X-Ray and AWS CloudWatch are kind of how you would typically get to your open telemetry data, right? So,
is there any nice integration with Aspire, Publish, and those services, or is it a manual integration?
no, not yet. So the big focus on Aspire up till now, and where we've been investing, has been in the local developer experience, right? That's been job one, because if that isn't right, there's no point in using it. I expect, as we continue our partnership with Microsoft, that the production story will get fleshed out in greater and greater detail over the next year or two, and as that happens, we will stay in lockstep with it. But for now, you would typically think of your AWS resources in two ways. The CDK stuff like queues and tables that we added, but for compute, you have the choice of where to go. The fact that your projects have been instrumented for OpenTelemetry is great. You can either use AWS X-Ray and CloudWatch to look at that. There are other systems out there that can monitor stuff in AWS other ways, so you have other choices. That's why OpenTelemetry is called open, so you have a lot of choice. But there is an easy standard path to looking at that. Other questions? In the blue, yes, sir.
We use Terraform to deploy to production.
Uh-huh.
So the dev cloud formation is fine, but I just wondered, is there a way to export like to a manifest or something?
Yeah. So Aspire already has something it creates called a manifest exactly for that purpose. We haven't done any work to go from the manifest to something else, but that's the direction it seems like things will probably take. Yes, sir.
Looks like you created the topics and the queues on initialization, it looks like. So how does it scale out? Like, does it look for similar topic names, or how does it scale?
How would we scale out back to 81 stores? Probably I would use an actual real message bus like AWS Event Bridge or a third-party enterprise service bus, that type of thing. You have the idea that you want to just really what you want to do is you want to publish on a topic, like this is an order for store number 13, and store number 13 is listening.
Yeah.
That an order came in and I'll take it, right? So that's ultimately where you want to go. I didn't want to add that level of complexity to this simple demo of what I was covering, but you definitely have options. So. All right. Well, just to recap what we saw, we started with nothing, but a UI. We added Aspire and got what we saw it to be an amazing dashboard. We added a DynamoDB table, access code really easy, using DynamoDB in the .NET persistence model. We connected the website and process order with messaging using, we added the Amazon CDK so we could allocate AWS resources from the app host project. And we saw SNS and SQS topics and queues created. We added an orders table Dynamo in the app host project, again with CDK. We added the store backend. We routed orders in a simple way to the store. And then we added feedback and computed sentiment. We used Amazon Comprehend for that. So hopefully this illustrates to you that Aspire is a super supportive playground in a sense to add things to see how they work with an incredible amount of internal visibility. Have you ever stopped and took a look in the mirror and taken a really long look and maybe noticed something new about yourself? The visibility you get from the way Aspire is designed is just amazing. And I didn't spend enough time on this, but in that surface discovery example where I deliberately broke the name of the service I was trying to find, and we used the traces to find it. The amount of detail you can get out of the dashboard to see these things, it's almost astonishing how much it knows. But in a world where so often things go wrong and you don't know how to debug them, it puts everything at your fingertips. So I have to say, I've been developing software for 40 years. Last couple of years I've been a product manager, but most of my career has been software engineer or software engineer manager. And this is the most, I started developing this, I'm very much like Oddball Pizza. I hadn't been coding every week for a while now, and I built this demo starting a week ago, and I hadn't used Blazor in a while, and so I was myself a little tentative. And you know what? I've never had more fun or been more productive in developing something. I have to say, I was already a fan, but now I'm doubly so. So tech we used, AWS Cloud Development Kit, CDK, the AWS SDK for .NET, Simple Notification Service, Simple Queue Service, the AWS Message Processing Framework made that easy to code in .NET, Amazon DynamoDB and the .NET Object Persistence Model made that easy to code, and Amazon Comprehend. As we go for more information, I recommend you follow our principal engineer, Norm Johansson, Socket Norm on X, to keep up with what he and David Fowler are cooking up as this advances readily. And this is our QR code there is for our GitHub location where you can find all that support. But if you have .NET 9, you already have this. All right. Well, thank you. I think our time is up. Thank you so much for coming.